Welcome to the lesson Hydraulic. The aircraft has two separate hydraulic systems powered by different engines to supply pressure to the hydraulically operated surfaces. The electrical backup to the hydraulic systems is provided in the event of a loss of the main engine-driven pumps. The hydraulic systems also provide a backup to the electrical system and the fuel system in the event of failures. The hydraulic system is divided into two parallel parts. These parts are designed to be kept separate. The yellow system is on the left of the aircraft. The green system is on the right. Normally, hydraulic power is supplied by two engine-driven pumps. The pumps are mounted on the accessories gearbox on numbers 2 and 3 engines. The pumps are running whenever the engines are operating. Each pump has its own reservoir of hydraulic fluid. The reservoirs are located in the hydraulic bay. The reservoirs are pressurized using bleed air from the same engine, driving the engine-driven pump. This provides a positive pressure on the fluid to the pumps, which prevents air being drawn into the system. This is known as cavitation. Each system has a switch on the hydraulics panel. The switches open isolation valves connecting the pump to its associated system reservoir. Switch engine 2 and engine 3 pump on. In an emergency, pulling a fire handle will close the isolation valve. The normal system operating pressure is 3,100 psi. A relief valve would open at 3,500 psi to avoid overpressure. There are no warnings of relief valve operation. There are also filters, accumulators, and non-return valves in both systems. An accumulator is fitted in the yellow system for the brakes. A second accumulator can be installed for the air stairs. An accumulator in the green system assists for startup of the standby generator. These services are supplied by the yellow hydraulic system only. Select a service for a closer view. These services are supplied by the green hydraulic system only. Select a service for a closer view. These services normally use both yellow and green systems because of their importance. Select a service for a closer view. The pilot can select yellow or green pressure to power the brakes. Normally, yellow is used. Normally, the hydraulic services are supplied by the two engine-driven pumps, as shown. Let's now take a look at the backup facilities which supply hydraulic power in the event of an EDP failure. If either EDP fails, an AC-powered pump automatically provides hydraulic power to the yellow system. The AC pump can also be used on the ground to pressurize the yellow system and therefore the brake accumulator, but not during engine start. Switch the AC pump on. If the number 3 EDP fails, backup is provided by a power transfer unit, PTU. In this case, the AC pump would also come on when in auto mode. The PTU combines a hydraulic motor which drives a hydraulic pump. The motor is powered by the yellow hydraulic system at 3,100 psi. Output from the PTU is delivered to the green system. However, the PTU can only generate 2,500 to 2,900 psi. Whenever green system pressure falls below 2,100 psi, the PTU will power the green system until pressure rises to 2,500 to 2,900 psi. No fluid is transferred between the systems, so the yellow system will not be drained if a leak develops in the green system. The DC pump is an emergency backup fitted in the yellow hydraulic system only. The DC pump has its own self-contained supply of hydraulic fluid within the yellow reservoir. It can continue to operate independently even if the main yellow system loses all of its hydraulic fluid. The DC pump can be powered by the aircraft batteries. This means it will still be available even if all the aircraft's generators fail. The DC pump only provides pressure for brakes and emergency main gear lockdown. During engine start, the DC pump can also be used to top up the brake accumulator. The AC pump should not be used during engine start because it would take too large of a load from the electrical power source. Look again at the DC pump switch. Moving the bulb enables the switch to be latched in the battery position. This would mean the pump is running continuously. The battery position is used during abnormal procedures only. Hydraulic backup to the electrical system. If there is a failure in the electrical system, the hydraulically driven standby generator can be used as a backup. The generator is driven by the green system. Immediate operation of the generator is ensured by an accumulator. The full green system pressure of 3,100 psi is required to enable a standby generator to give a constant frequency. The only way 3,100 psi can be guaranteed is by isolating the green system from the main green hydraulic services. This happens automatically when the standby generator is operating. When this happens, the pressure shown on the green hydraulic gauge remains 3,100 psi. However, the green system low pressure annunciator and the hydraulic warning on the central warning panel will illuminate to draw the pilot's attention to the loss of green system services. The white standby generator on annunciator on the electrics panel will also illuminate. If EDP3 fails whilst the standby generator is operating, the PTU is turned off because it is not capable of delivering sufficient pressure to run the standby generator at the constant frequency required. The yellow system provides pressure for the hydraulically driven standby fuel pumps if the aircraft suffers an electrical failure to the essential level. With the yellow system fully pressurized, the pumps will operate automatically. Operation of the pumps does not affect operation of any yellow services. Before entering the hydraulic bay, you should ensure that the air brake and lift